Friday Bytes by Helixz.
So guys, today I'm going to talk about scalability. So scalability is basically about how a system handle growth. So think when more people start using an app, the system should not slow down or crash. Basically, good systems are designed to grow smoothly from the beginning. So let's talk about them. First, I will explain what scalability means. So then how systems grow, and after I will explain different way systems are scaled. And finally, I will summarize the key points. So what is scalability? So scalability means, guys, the ability of a system to handle more works by any resources. So think when users increase, we add more resources instead of rebuilding system. So basically, scalable system maintains good performance and reliability even as it grows. So it's guys, it is what it is. So guys, and then we can talk about how can system grow. Uh, a system doesn't grow by only users. So it can grow in many ways like users, features, complexity, data, and geography. So basically, scalable system maintains good performance and reliability uh, by overcoming these challenges. So let's talk about them. So dropping users and features. So you all know when more users join to the system, the number of requests increases. For example, the social media app becoming popular overnight, it makes our system grow more. And then when the users come into the system at the same time, the system keeps adding new features to the system. For example, there is a business application. When it's beginning, it's very simple. By the way, but it's when growing, we have the new features like new payment methods, and AI features likewise. So more features mean more processing and more load on system. So then we can talk about growth in data and complexity. So you all know every time users use a system, data is created, like videos, message, images, and logs. So all the data keeps increasing over time. So then what is complexity means? Earlier we talked about features. Basically, when more features are added to the system becomes more complex. So a simple application slowly runs into a complex system with many components. That's how a system become more complex. So then we can talk about growth in geographic reach. So as you all know, when the system serves users from different countries, distance affects the speed and availability. So that's why global system must be designed to work well everywhere. So guys, now let's talk about how we overcome these challenges by discussing all of them. Uh, yeah, scaling strategies and overview. So how do we handle all this growth? We use different scaling techniques. So there is no single solution in real world applications. So in real world systems, we use combination of these strategies to overcome these challenges. So let's talk about them. Yeah, vertical versus horizontal scaling. Simply, what is vertical scaling? Uh, Vertical scaling means updating one machine. We add more RAM, more CPU, more storage to increase the capacity. So this approach is works well, but there is a limitation. Why we cannot add as much as possible to single machine. So that's the reason um, we cannot expand our system. So then what is the horizontal scaling? Then horizontal scaling means adding more machines and distributing the work across them. So approach is more powerful and flexible, and this method is used widely in real world large applications to handle their workload. So then we can talk about load balancing, caching, and CDN. So load balancing, what is load balancing do? So load balancing do distributes request evenly so that no single server becomes bottleneck or overloaded. So it uses their own algorithms like IP hashing, roving around to handle this traffics. So then what is the caching? In simple terms, caching means caching stores frequently used data in memory. So it loads faster and reduces the database querying every time. So it can improve the system performance. At the end, we can see what is a CDN or content delivery networks. So basically, CDNs deliver static contents like images, videos, like images or videos. So this helps the users to get faster response as much as possible. For the example, we can take Amazon CloudFront or Cloudflare. And you all know, I think it's 70% of internet depends on these CDNs. So then we can see how CDN works. Think if user requests data from CDN, if CDN have that data, it returns that data to user. If it is not found, CDN call to main server and take it back to CDN and return to user. That's how CDNs are working. And then we can see advanced scaling techniques. So what is the sharding? Sharding means splitting data across multiple servers, like partitioning a database into small parts. So basically, this prevents one server from handling too much data and too many requests at the same time. So it is the definition of sharding. And then we move into asynchronous communication. So asynchronous communication moves slow or heavy applications to background. So once the task is completed, the result is returned. That's why applications don't freeze while processing. So in JavaScript, we can see event handling, event looping do this job greatly. So then we can move into modern scaling approaches. So microservice architecture. So microservice means it splits a system into smaller independent services. So each services can scale separately, and main advantages of microservices are reduce the single point of failures, and it improve the reliability of the system. So microservices are very commonly used architecture in heavy applications. So let's talk about auto scaling. So simply auto scaling means it automatically increases or decreases the number of servers based on traffic. So cloud platforms like AWS handle this automatically as our data is coming to their servers. So finally, multi-regional deployment. Earlier we talked about, as you remember, we talked about geographic growth. So this approach helps to overcome those challenges by improving speed and reliability. So we can deploy our applications in different regions to overcome this challenge. So finally, it occurs. So finally, I won't say scalability is essential for growing system, because systems grow in many ways. So as we talked about earlier, good systems use multiple scaling techniques together. So that's why scalability should be planned from the beginning. So it makes system reliable, flexible, and future-proofing. So thank you, guys. That's it for today. Thank you.